In this video, I'm going to quickly demonstrate 3 examples of how our BigQuery customers are using Apache Spark to extend the functionality of BigQuery for more advanced analytics. BigQuery is Google Cloud's highly scalable enterprise data warehouse solution. It's fully managed, it's serverless, it offers real-time insights from streaming data, it's got built-in ML out of the box, and high-speed in-memory BI engine for faster reporting and analysis. And with that full stack, obviously it duplicates a lot of the functionality of Spark when it comes to things like SQL at scale, automated data transfers, ETLs, streaming, ML, and a lot of the basic reporting capabilities. So this video, I'm not going to get into all the differences between the two. That's a much bigger conversation. Rather, I'm just going to quickly show a few common ways Spark, on top of BigQuery data, can extend BigQuery's capabilities. Now, this extension is made possible by the spark-bigqquery-connector. It's created by Google's Dataproc team, but it's fully open source, so you can go grab the jars from any Spark deployment or even go look at the source code. It was created on top of the BigQuery Storage API and the Spark Data Source API. Originally, it was really designed for customers that wanted to move everything to BigQuery, but they didn't want to rewrite all their Spark jobs when they did. However, we have found that customers are using it for some new use cases too. And that's because of, just the nature of the cloud. The nice thing about the cloud is that you can augment your BigQuery with some Spark without having to go and invest in a full second Hadoop platform or anything. You just use the API, you spin up some Dataproc clusters for a one-off use case or to experiment, and then shut those down. So let's look at a few of those use cases now. The first reason that Spark gets used with BigQuery, which I'm going to show you in this video, is just for more Pythonic data manipulation. Lots of data scientists or data engineers that I talk to, they really have 2 core tools, SQL and Pandas, which is a Python API. Now, SQL, it's the language that's used for storing, manipulating, retrieving data, and BigQuery does this extremely well at scale. Pandas, it's a library in Python used for a data analysis and manipulation. And it has a ton of built-in functionality for stuff like time series data, preparing data for statistics and machine learning. But if you try to use like a regular Pandas API on top of a BigQuery-sized data set, a lot of time it just blows up and you run out of memory on your laptop or whatever it might be. And so this is where Spark really comes in. Spark has a package called Koalas that offers most of the Pandas API, but on top of a Spark data frame that can handle those large BigQuery tables. I'm going to show you an example of Koalas using the US COVID public forecast data. The second reason for using Spark with BigQuery is to take advantage of the spark.ml framework, which will let you build complex and custom machine learning pipelines. Now, for simple ML pipelines, BigQuery actually has a lot of machine learning functionality built directly into the SQL language, which works really well for if you want to stay within SQL. But a lot of times if you have those hairy, complex pipelines, you might be pulling from multiple sources, running custom logic. Customers tend to gravitate more towards running something like a spark.ml. Now, Kubeflow Pipelines is another tool that customers use for these advanced ML pipelines against BigQuery, and it has almost an overwhelming amount of functionality. But I personally find spark.ml is just a little bit more approachable, and typically spark.ml can build the pipelines I need without having to go and venture into the full Kubeflow world. I'll show an example of using this spark.ml API using a Hacker News dataset in BigQuery, where I'll build an ML pipeline that helps me identify what will be a successful internet article. The third demo I'm going to show today will just be on distributing generic Python functions. Sometimes you might have a piece of Python code that takes an action, like it'll email the customers that come back in your data set in the query results, or it updates another inventory system based on what the new orders are that came in. Or maybe it's just code that was written years ago and you don't want to touch it because it's gone through an external audit and compliance review. So Spark UDFs are a really easy way to scale those functions across your BigQuery data. I'm going to show an example of a Python UDF that labels images from the Open Images dataset. Now the tool I'll be using today is Dataproc Hub, which is a managed solution that lets me create isolated and fully configured Spark notebook environments directly from the Jupyter interface using templates that may have been set up by a separate IT staff. And while I am using Google Cloud Spark tools because it saves me from a lot of the setup and configuration and just makes it really easy to run optimized open source libraries, I did want to call out that Google does stay true to the open source APIs and separates processing engines like Dataproc and Dataflow from the actual open source libraries like Spark and Beam. So everything I'm going to show you today should also work from a platform like Kubel or Databricks. It might just require some additional security and networking setup. Okay, with that, let's get started. Okay, so I'm in the Google Cloud Console, I'm in Dataproc, and I'm in the Notebook section. What I'm going to do is I'm going to jump onto this Dataproc Hub instance. This is already a running Dataproc Hub instance. If I didn't have one, I could come up here to New Instance and create a Dataproc Hub spawner for Dataproc clusters. But I don't need to do that since I have one running. I'm just going to jump into this URL, which basically is a landing page for Jupyter Hub. And this is a URL that I could essentially give out to different folks who need to access, a way to spawn Dataproc clusters. So I have a couple different cluster configurations to choose from. I could pick to spawn a Jupyter environment based on a data engineering cluster or a machine learning cluster. These can be anything. If you're wondering where these come from or how to create these templates, if you just come back into Dataproc and take a look at running clusters that you have, or even I don't even have any running clusters, but this could even be done off of a stopped cluster. I can just go gcloud Dataproc export Dataproc clusters, export maybe that test logs cluster, give it the region Control 1, and I have to tell the destination where I want to dump that a template here, and we'll just call it test logs template YAML. Let's see if I got that right. Okay, it looks like it worked, and just so you can see what you're looking at here, or what that template looks like, logs template YAML, and that is all the information associated with that cluster that you can use that to go and create one of these templates. So anything that you want according to your specifications, you can get that. So I'm going to pick this machine learning cluster. I do have the ability also, depending on my permissions, I can customize this with some additional configurations. Like maybe I want to override the Hive Metastore setting to connect to a Dataproc Metastore. I'm not going to do that right now. I'm just going to go ahead and create myself a machine learning cluster. This process will take a couple minutes, so here I'm going to pause the video and come back once the cluster has been spawned and I'm attached to it. Okay, so I'm in my Jupyter Lab environment that was created for me. And first use case we're going to look at is just this Pythonic approach to BigQuery data manipulation. So the problem I'm trying to solve with this is just that BigQuery is the best place to run SQL, yet I still often find myself limited by some of SQL's just basic and inherent functionality. So normally, you might be working with a combination of pandas and SQL, but you run into the issue where pandas just won't scale to the size of these BigQuery tables. And SQL can be kind of verbose and hard to maintain. So I'm sure if any of those of you that have come from a heavy analytics background, you've seen those 100-line SQL queries with all that logic, and they're just can be very difficult to maintain and know what's going on. Pandas can really help you wrap all that up, version control some of that with GitHub. And the SQL analysis, the tools are really on reporting, and the data. A lot of what Pandas will bring is functions that perform the advanced statistics, machine learning and time series analysis. And so, if you really are wishing to bring those advanced Pandas capabilities to BigQuery scale data, this is the package to go and look for. It's Koalas, brought to you by Databricks. Now, here's the first time I'm going to show you how to actually go and connect Spark over to BigQuery. So you just have to be in a Python 3 kernel. Don't use the PySpark kernel. And then import the Spark session, create a builder. Now the first thing that I do in this initial Spark session is I just create a generic builder, and then what I do is I go and just pull, what version of Scala I am actually running here. So if I separated this out here, what that line does, just pulling back 12 to let me know what version of Scala I have, and I put that in. And the reason I need that is because in the connector I have to just define, which jar is specific to the version of Scala, and I'll pull that in here. I also, while I'm in here, setting up this session, I'm going to enable Hive support. And if I use this get or create, it doesn't matter that I've already created a session. I can just override that. So I'll go ahead and set that up. And now, once that's enabled, to go and pull back a BigQuery data, it's as easy as just calling spark.read. You declare the format is BigQuery, and then I load the table that I want to call. Now I can put additional filters and predicate pushdown on top of this function, but here I'm just going to pull in this whole data set. And I'll just show you real quickly what this looks like. This is kind of a bad example of what I want to show of what the data looks like. I'm going to filter out, just because everything here is unknown. So what I actually want to do here is just filter these out. County is not equal to unknown. Let's see what that gives me. Okay, this is a little bit better understanding of what's happening here. You have this data set has a day, and for every day, for every county, for every state, has the number of confirmed cases and the number of deaths due to COVID. Now, this can be, a very difficult data set to work with using SQL alone. Great example of where we might want to pull in something like Pandas and Python. So, because all I have to do is once I've added Koalas to my Conda environment, I can just import it from our friends at Databricks. And once I've imported this statement, it should be smart enough to extend the Python, the Spark data frame to let you just go, to Koalas and do that conversion. And let's call that and see if it worked. And this is just, the basic describe that I would expect to get, from a Pandas output here. Telling me, mean, standard distribution, min, max, that sort of thing. Now, why this is an example of a data set that would work well in Pandas, it's because often in machine learning and stats, we want to transpose these columns. So like to send a data set like this into a machine learning algorithm or even a statistical algorithm, you really would have to go through in SQL and just say, for every one of those states and counties, sum up those confirmed cases, sum up those deaths. We want to aggregate those, not by day. And then you got to repeat those for every single county in the United States. So that's like 800,000 rows of SQL. Now, obviously, you might want to automate that, but instead of writing your own automation, you can just use something like Koalas, which just has a one-line. I have a transpose function .t, and essentially I can just I'll group by to get rid of the dates, sort it, and then I'm going to transpose the whole thing. If I run that, now here I have every single county in the United States by state. So the states are here, the state, and then the county, and I can see how this is all split up. Another really popular reason folks use these preparation steps from Pandas is it has things like like get dummies. So if I wanted to then take this data, I won't do this, but if I wanted to do this and just send. If I had a lot of categorical data, maybe, so it won't work on this data set, but if I had a lot of categorical data, just a very quick way to go get dummy variables for all that, Pandas makes that possible. And then just in general, there's just a lot more just ease of use for data manipulation. So here's an example where I'm looking, I wanted to do a death rate, deaths by confirmed cases. And, something like this, I could do it in SQL, but it would take a decent amount of querying on top of subqueries, where this is now just 3 lines of code, and I can even do a quick plot within the same tool to check on it. And obviously, as you get into things like time series, there's a lot just more built-in Pandas functionality designed for that specifically. Okay, so I showed you a little bit of how to do some data manipulation and preparation. But now the question, of course, comes, how do I put this into a full machine learning pipeline? Now, the example I'm going to show you in this Advanced ML Pipelines actually comes directly from the spark.ml tutorial, but I liked it because it addressed a real problem that I have, which is, as a PM, I write lots of blogs, and I want to know, before I put them out there, like this internet article I'm about to put out, how well do I think that's actually going to be received by readers? So what I'm going to do in this is take a Hacker News public data set that's available in BigQuery. It has the full text of all these articles and a score associated with how well accepted that article was. And I'm going to build a machine learning pipeline to try to predict those scores, and then I'll feed my own blogs into it to get an understanding of, hey, is this successful or is this not? Now, before I jump in, I want to give a quick primer on SparkML itself. It's based on a few core concepts. First of all, the data frame itself, which is just the Spark data frame that you may already know about. And this data frame is actually the differentiator between spark.ml and mllib, the previous package for machine learning in Spark. All the spark.ml is based on the Spark data frame. There's also going to be a transformer, which is actually how you transform data frames into other data frames as your pipeline is built. And then the estimator, which is the actual algorithm that you would typically run like a fit on to produce a transformer. And there's also the pipeline itself, and that's how you actually tell it, here's the transformers and estimators that I want to run together in my workflow. And then there's parameters that work against both the transformers and estimators. If you're coming from a scikit-learn world, this should look pretty familiar. And I can just to show you what we're going to work on. Again, I said it's coming directly from the Spark documentation, but this is what we're going to build here in this notebook. Is we're going to have a token. It's going to be working on text. We're going to tokenize the text, turn them into words, hash it, and then come up with a logistic regression model that tells us, hey, is this article going to be, is this a good article or is this not a good article? Again, we're going to start with our boilerplate code, pulling it back, setting up with our BigQuery support. Then we're going to go ahead and read a sample of the Hacker News data set. So this is Spark. You could scale it to the entire Hacker News sample, but just for the purposes of this tutorial, I'm just pulling back a sample, and I'll show what you can see here. Maybe not all that telling about what this data set looks like. Let me just do a quick show. So you get the idea. There's a bunch of text associated with a score, and just so you know, this is actually, you can see when I don't truncate it, you can actually see these are actually the full articles, the full text articles. Okay, so now we're going to actually jump into preparing the data, this Hacker News data, because we do not, the tutorial just has a sample data frame that you create. We're going to do this off of some real data. So the easiest thing for me to do is, I already have this data frame in Spark. I register it as a temporary table, and that lets me run some basic SQL functions against it. So what I'm going to do here is I just send some SQL. I'm going to treat that same data frame as a SQL table, again with SQL. I could do this in BigQuery, but it's easy enough to do here. I want a random number generator, and then you'll see why in a second. This is really just to break up my training and test set. And then I want to use this logistic regression model. So it's all or nothing. The score is a number, with a mean of 8, but all goes all the way up to 1,000, between 1 and 1,000. So what I'm going to do is I'm going to basically pick 10, which is just a little bit over the mean. Say, hey, if it's over 10, it's a successful article, else 0, it's not successful. And I'll use that as my label. From there, I just do a quick group by to show how the random numbers, were distributed. And then I pick, about 10% to hold back. And that's the holdback that I use here. And here, where I say it's either in that holdback or not in that holdback for the, the training set or the test set. I'll create my data frames that I'm going to send off. I do a quick check before I go into the ML pipeline, where I just look for the training and say, hey, how many labels are actually positive? Or sorry, how many labels? Yeah, were they positive? About 91 out of 1,000. That's about 10%. That's not too bad. So we're going to continue forward. Okay, so this is the the key to this is the 3 packages we're going to import for the pipeline. The pipeline itself, a logistic regression classifier, and then for the features, hashing and tokenizer. So quickly, just to see, walk through what this is doing. The tokenizer is the tokenizer. It's going to input columns. The input column is the text, which is the full Hacker News dataset, and we're going to output all the words. The next transformation is this hasher. It's going to read as an input column the tokenizer's output column, which is the words here, and then it's going to output a new column called features. And then we're going to set up our logistic regression with just a couple hyperparameters, and set the whole thing into a pipeline where here are my 3 stages that I care about: tokenizer, hashing, and then logistic regression. Obviously, you can get a lot more complex than this, but this gets you the idea of the idea of how you build these pipelines. Then, I can fit that pipeline to the actual Hacker News articles. This is what, doing this training does. And then once I have that, I can review what got trained against, my test data set. And I just do a quick, check here where I loop through, and I'm actually just looking for predictions greater than 0, so I can see that I did have a few positives. Seems like our model's doing, working decently well. So now what I want to do is I actually want to use this model to decide, what blogs should I use. So I took a sample of a blog that I wrote on a topic about a Dataproc topic. I also took one that our product marketing manager wrote, and then I took one that my boss wrote. And I created a data frame that actually set up a data frame that has those 3 blogs. And then all I have to do is run, transform using that model that I just trained above and off the Hacker News data set, and then we can do some predictions. And it looks like, our product marketing manager is the one who got it closest. He's going to be the one that's most successful, so we should probably go with his blog. And this is only trained off about 1,000 rows of a sample, but if we were going off all the millions of records in the Hacker News dataset, we would obviously want to, it might take a while to train that model, and we can just save the result of that off to cloud storage when we're completed. Cloud storage. So the third and final demo I'm going to show real quick is distributing generic functions using Spark. In this example, I'm going to use the Open Images dataset, which has 9 million URLs of open images. Now that dataset actually does have labels with over 6,000 categories, but in my example here, I'm going to just show how, if you're coming from the real world, you probably are often collecting a lot of image URLs and you don't know what's in that information. And so in this example, I'm going to show how I could have a Spark UDF that helps me label all of the different images, all of what's in an image using the Cloud Vision API. Now, just to level set, I've shown how we've jumped directly into Spark a few times, but for smaller data sets that do fit into Pandas, there is a BigQuery magic available in all of these notebooks where I can just have my BigQuery SQL query pumped directly into a regular Pandas data frame. I can even call it over the storage API so I can get the high throughput performance. And then what that does is, I have just a typical Pandas data frame on a single node. And this is just kind of giving you an idea of what was in that, Open Images dataset. And there is a original URL, and then there's a title associated with it. But if I'm, a PM and I'm looking for some open images and I want it, that I can use for a, like a presentation, knowing that the title is DSC 4918 is not necessarily overly useful. I really want to know what's in these images so I can figure out how to go pull things quickly and filter it. So what I can do is I have using the Vision API from Google Cloud, I can just go quickly annotate any image, all the images based on their original URL. And what I actually want to do is a little extra logic. I just want to be certain that, with high confidence, I just want to do a big filter and just say only the images that are over 90%, that's what I want to tag. And so because I have that high threshold, I also need to account for that some images are probably not going to have labels, just no labels detected. And so this function, I could run this just in a for loop across those 10 images, and without much trouble, you can see how it goes into work, and I can start getting labels associated with these original URLs, which is cool. But that works for 10. This has 9 million images in the data set, so we really want to take advantage of something like Spark to let that scale, and I'm going to show you how to do that next. So I want to expand to that full corpus of images with Spark. For this particular demo, I do still, I could pass whatever query I want. I'm still going to limit it to 10 just so we can get through the demo, but I'll also show you at the end how you can run this on the entire corpus using Dataproc and Spark. So this section here is our, this is our boilerplate code again. Now I've shown this boilerplate code a couple times. Just one quick, tip that I use is I often keep these files like on a local store, and then I just load them in as I need them. That way I'm not just rewriting the same boiler templates again and again and again. I kind of know what I need. So this has an additional function that I haven't shown you yet. And in this example is I often have, some, even if it's not super sophisticated, I really want to push all the SQL logic back down to BigQuery as much as I can. That's where I want my processing to happen, and this function really lets me do that. What it does is it lets me pass it an arbitrary query, and then it actually uses the BigQuery API first to materialize that result on the BigQuery side, and then I can use the same spark-bigqquery-connector to actually go and get the pull from that result set instead of just expecting all that data to come across and then have Spark do the processing. It's easier to push it down as much as possible. You can also set exactly how you want this to be cached. I think so. I'm telling it that if you run out of memory, go ahead and build a disk, and we can see what this example looks like. Okay, and I did pull back. It looks like the right schema, same schema we were using before, original URL and title. And now I want to do is kind of Sparkify that other function. The same thing that we did up here, I can actually do the exact same thing with a Spark UDF simply by having the decorator of UDF tagged once I've imported UDF from pyspark.sql.functions. And this is really, I think you have to give it the type that comes back. I believe I don't even have to write string because the default type is string, but just so it's clear, what I'm, what it's expecting back. I'm pulling back a string of these high confidence labels. And then when I, have that Spark data frame, I can run my, get the original URL, get the title, but I can also run that UDF, pass it that URL, and then alias this label, so I also get my labels back. And so you'll see it'll look something, along the lines of this, where I have each original URL. I have, the title that was, not always overly helpful, but I also have now, the labels that would be helpful if I'm trying to figure out what's in these labels. So this one's, people, comfort, hand, child. Yeah, people, comfort, child. Looks about right. Now when these, after you run a big, UDF against this full data frame and try to cache it, what you probably want to do is you probably want to save that off. In this example here, I'm just writing as a save as table, which writes it to my attached Dataproc metastore. So that is, lets me keep it on, as a data mart on my side. But you could also write that back to BigQuery as well if you wanted these, back into the data warehouse. And then finally, what that really lets me do is I now have these functions where I can just do some basic, hey, look at all these columns, like, I need a picture of a bird. What comes back with a bird? And I can see very quickly across the all the updated images, like what birds, I could go and pull. So, organism, bird, okay, there's an example of a bird. And then again, here's another one, bird, another choice for a bird. Now I pointed out that I cheated by, I just wanted to get through, I wanted to show you in the notebook quickly by just, setting all this up with my limit of 10. But when I'm actually ready to run this entire, at scale, I typically want to leave the notebook behind. I don't want to necessarily babysit this job in a notebook. I'd rather have Dataproc do that for me. So when I come back into the Dataproc console and come to jobs, I'll actually submit that when I'm ready to do this at scale, submit it as a job. And I'll pick, maybe the same cluster I was on, but you can also have a different cluster that you might want to use when you want to do something at scale. I'll call it PySpark. I'll use a PySpark job type. I'll just go ahead and pick that. It doesn't matter. You point the job at your a Python file, and then don't forget to add your jar to make sure that you can go and hit. That's what gives you access to go and hit BigQuery, and you can go and kick off that job. When you do this at scale, definitely want to check out perhaps the auto-scaling policies that are available. We give you plenty of templates to make it easy to go and pick what you might need. If you are just on a single cluster just for you and you're just running one job, you probably want this policy to never scale down. That'll just scale up to meet the demand of that training job that you have. You just want to make sure that you set the limits on that to a cluster size that you're okay paying for. All right, with that, I will all three of these examples will be uploaded to the example section of the BigQuery storage connector on GitHub, and please reach out if you have any questions. Thanks.